we know that the sum of angles in a triangle is equal to 180 degree. So in this right angle triangle, angle C is 90 degree, angle A is theta. So what will be the measure of angle B? Well, angle A plus angle B plus angle C is equal to 180 degree. Now angle A is theta, angle B we have to find out, and angle C is 90 degree. So angle B is equal to 180 minus 90 minus theta. So 180 minus 90 minus theta, which is equal to 90 degree minus theta. So angle B is equal to 90 degree minus theta. Also, the sum of angle A and angle B is 90 degree, because this is 90 minus theta and this is theta. 90 minus theta plus theta is 90. So sum of angle A and angle B is equal to 90 degree. Or we can say that angle A and angle B are complementary angles, because when the sum of two angles is equal to 90 degree, the angles are called complementary angles. So if angle A is theta, angle B will be 90 degree minus theta. So in a right angle triangle, these other two angles apart from the right angle are always complementary angles, because their sum will always be equal to 90 degree. Now let us find the value of sine theta and cos theta from here. Sine theta is equal to opposite by hypotenuse. So the opposite side of theta is BC. So this is BC by hypotenuse, that is AB. Cos theta is adjacent by hypotenuse. Adjacent side is CA and hypotenuse is AB. So it is CA by AB. So this is what we have. Sine theta and cos theta. Now let us find the value of sine and cos for this angle, 90 degree minus theta. For 90 degree minus theta, this is the opposite side, CA. So sine of 90 degree minus theta is opposite by hypotenuse, that is CA by AB. So this is CA by AB. Cos of 90 degree minus theta will be adjacent by hypotenuse. This side is adjacent to this angle. So it is BC by AB, because adjacent by hypotenuse. So this is BC by AB. So this is what we have. Now observe something. BC by AB, and we have BC by AB here. So sine of theta is equal to cos of 90 degree minus theta. Also, we have CA by AB here and CA by AB here. So cos of theta is equal to sine of 90 degree minus theta. So sine theta is cos of 90 degree minus theta, and cos theta is sine of 90 degree minus theta. That is, sine of an angle is equal to cosine of the complementary angle, and cos of an angle is sine of the complementary angle, because theta and 90 minus theta are complementary angles. So we can say that sine and cosine are complementary ratios. These two trigonometrical ratios are complementary ratios, because since A and B are complementary angles, sine of A is equal to cos B, cos A is equal to sine B. So sine of an angle is equal to cosine of the complementary angle, and cos of an angle is equal to sine of the complementary angle. So now you see where the name cosine came from. It is the complementary of sine. That is why it is called cosine. That is complementary of sine. So sine A equal to cos B and cos A equal to sine B in a right angle triangle. So now can you answer this question? Sine 37 degree equal to cos of what? Well, we know that sine of an angle is the cosine of the complementary angle. That is, sine theta is equal to cos of 90 degree minus theta. Now if we substitute theta equal to 37 degree, then sine 37 degree is equal to cos of 90 degree minus 37 degree. Now 90 degree minus 37 degree is 53 degree. So this is equal to cos of 53 degree. So we have sine 37 degree is equal to cos 53 degree. Since 53 and 37 are complementary angles. If you add 53 and 37, you get 90. So since 53 and 37 are complementary angles, sine of one is equal to the cosine of the other. Now again, for theta and 90 degree minus theta, find cosec and sec. Well, cosec theta is the reciprocal of sine theta. So it is equal to AB by BC. Sec theta is the reciprocal of cos theta. So it is equal to AB by CA. Cosec 90 degree minus theta will be the reciprocal of sine 90 degree minus theta. So the reciprocal of this, which is equal to AB by CA, and sec 90 degree minus theta is the reciprocal of cos 90 degree minus theta, which is AB by BC. So this is what we have. Now observe that this is equal to this. So sec theta is equal to cosec 90 degree minus theta. This is equal to this. Also, cosec theta is equal to sec 90 degree minus theta. We have AB by BC in both. So this is equal to this. Or we can say that sec of an angle is equal to cosec of the complementary angle, or cosec of an angle is equal to the sec of the complementary angle. That is, secant and cosecant are complementary ratios. So secant and cosecant, these are complementary ratios. So that is where the name comes from. Co stands for complementary. So this is the complementary of secant. So in this triangle, A and B are the complementary angles. So cosec A is equal to sec B. Sec A is equal to cosec B. So if the angles are complementary, we take the ratios also to be the complementary. Sec A is equal to the complementary ratio of the complementary angle. What is the complementary ratio of sec? Cosec. What is the complementary angle of A? B. So sec A is equal to cosec B. Now can you answer this question? Sec 41 degree equal to 1.325. Find cosec 49 degree. Well, we see that this is 49 degree and this is 41 degree. 49 degree and 41 degree are the complementary angles, because 41 degree plus 49 degree is equal to 90 degree. Also sec and cosec are complementary ratios. So we have sec 41 degree is equal to cosec 90 degree minus 41 degree, because sec theta is equal to cosec 90 degree minus theta, which is equal to cosec 90 degree minus 41 degree is 49 degree. Now we already know that sec 41 degree is 1.325. Therefore, cosec 49 degree is also equal to 1.325. So the value of cosec 49 degree is also equal to 1.325. Now let us find the value of tan theta and cot theta. Tan theta is sin theta divided by cos theta. So BC by AB divided by CA by AB, it gives us BC by CA. So tan theta is BC by CA. Cot theta is the reciprocal of tan theta. So it is CA by BC. Now tan of 90 degree minus theta is the ratio of sin 90 degree minus theta and cos 90 degree minus theta. So it is the ratio of CA by AB and BC by AB, that is CA by BC. So tan 90 degree minus theta is CA by BC. Cot 90 degree minus theta is the reciprocal of tan 90 degree minus theta, that is BC by CA. So this is what we have. Now we see that CA by BC and CA by BC here. So cot theta is equal to tan 90 degree minus theta. Also tan theta is equal to cot 90 degree minus theta. So tan of an angle is equal to cot of the complementary angle, and cot of an angle is equal to tan of the complementary angle. So tan and cot are complementary ratios. That is why tangent, cotangent. Co stands for complementary of tangent. So these two are complementary ratios. This means that tan of an angle is equal to cotangent of the complementary angle. A and B are the complementary angles. So tan A equal to cot B and cot A equal to tan B. So if we take cot A, so if we write the complementary ratio of cot, that is tan, we need to write the complementary angle of A, that is B. So cot A equal to tan B. Now, if you remember these two relations, then you can derive the remaining relations from these two. How? If you divide sin by cos, you get tan theta. And if you divide cos by sin, you get cot 90 degree minus theta. Similarly, if you divide cos by sin, you get cot theta. And sine 90 degree minus theta divided by cos 90 degree minus theta gives you tan 90 degree minus theta. So you get this on dividing 1 by 2, and you get this on dividing 2 by 1. So you can derive this from this. Also, if you take the reciprocal of this, then 1 by sine theta is equal to cosec theta, and 1 by cos 90 degree minus theta is equal to sec 90 degree minus theta. If you take the reciprocal of this, then 1 by cos theta is equal to sec theta, and 1 by sine 90 degree minus theta is equal to cosec 90 degree minus theta. So we have this. So simply these two will give you the remaining relations. So these are the relations for complementary angles. So we have sin A equal to cos B, cos A equal to sin B, tan A equal to cot B, cot A equal to tan B, cosec A equal to sec B, and sec A equal to cosec B. So sine and cosine are the complementary ratios. Sec and cosec are complementary ratios. Tangent and cotangent are complementary ratios. Now can you evaluate this expression? Well, we have sine 35 degree, cos 55 degree, cos 35, sine 55, cosec 10 and tan 80. These are not standard angles like 0, 35, 45, 60, 90. So we do not know the values of sine 35, cos 55. Then how do we evaluate it? If you look carefully, you will observe that 35 and 55 are complementary angles. Also, 10 and 80 are complementary angles. So let us try and see if we can use the properties of complementary angles to evaluate this. This gives us, now sine 35 is cos 55, because 35 and 55 are complementary angles. So sine of an angle is cos of the complementary angle. Sine 35 is cos 55. So we have cos 55 into cos 55, which is cos square 55 degree. In this case, we have cos 35 and sine 55. So let us convert cos into sine so that we have 55 degrees. Now cos 35 is equal to sine 55 because 35 and 55 are complementary angles. So sine 55 into sine 55 is sine square 55 degree. So this gives us sine square 55 degree. Again cosec and tan. Now cosec 10 degree is equal to sec 80 degree because cosec and sec are complementary ratios and 10 and 80 are complementary angles. So cosec 10 degree is equal to sec of 90 degree minus 10 degree, which is equal to sec of 80 degree. So cosec square 10 degree is equal to sec square 80 degree minus tan square 80 degree. Now, we have cos square 55 degree plus sin square 55 degree. We know sin square theta plus cos square theta equal to 1. That is an identity. It holds for all values of theta. So, cos square 55 degree plus sin square 55 degree will be equal to 1. We also know that 1 plus tan square theta equal to sec square theta. This is another identity. So sec square theta minus tan square theta will be equal to 1. It holds for all values of theta. So if we put theta equal to 80 degree, then sec square 80 minus tan square 80 will be equal to 1. So this is 1 and 1 by 1 gives us 1. So we see the value of this complex looking expression is 1. And you see we have solved it in 3 steps using the properties of complementary angles and the trigonometric identities. So it is very important to learn complementary angle.